Hello folks. Okay, I just wanted to go through a little bit of Lab 1 and see how we go here. So the idea is to essentially give an introduction to Lisp. So writing functions, calling functions, a little bit of recursion, a lot of lists, input, output, that kind of thing. So just make sure everybody's up to speed on all the basics. So I guess I should recap just in case you're having trouble finding the Lab 1 info. Again, from the main page, it's hit labs, and there's the usual blurb about late penalties and all that kind of thing. If you need any refreshers on Git and whatnot, there are links there, and some instructions on how to eventually get your feedback once it's done. And then Lab 1 is today's. So this one's due on Monday the 25th at noon. And again, basically the idea is I'm going to provide you with a couple of starter files, and you're going to be implementing some functions pretty much and testing them out. So again, we're going to be using Git to distribute the code for the labs. I'll be using Git to get you to submit it. This is pretty much the same process as we use in all the upper level courses for CS. So if you haven't done it before, have a view through the different videos that are there. And if you have, again, for this year, it's just CSCI 330, and this one is just called Lab 1. So the usual blurb of instructions, if you haven't got a 330 directory yet, you should probably create one. Fork, clone, cd into your Lab 1 and work away as much as you like. And then the usual cycle of adds for any files that you change, commit at some point, and push. And again, if you forget to add a file, it won't get back to me. If you forget to commit, it won't get back to me. And if you forget to push, it won't get back to me. So, usual idea with all of our Git joy. When you grab your Lab 1 repository, the contents are going to look something like, let's see, something like this, where you'll have two Lisp files, lab1.cl and test1.cl. Test1 is an executable script. Lab1.cl is basically just a bunch of function definitions that you're going to be completing. Actually, you'll probably also see a README when you grab this. Since Git isn't actually up and running at the time that I'm recording this, we're just kind of faking it here. So, if you have a look at the two files there, lab1.cl has basically got empty function definitions. So there's a checker function, a processor function, and a main function, and you're going to be completing all three of these. And at the moment, all that's inside them is a statement saying, yeah, this function got called. So just so you can check and see if they're actually running at the moment. Obviously, you're going to want to change that as you see what the lab requirements are. So all that's going to be in your lab1.cl are your three functions once you've completed them. Nothing else. No hash bang, no other function definitions, no variables other than, if you wind up with local variables inside the functions. But again, no global variables, no def vars, etc., etc., etc. So in the other one, the test1.cl, basically it's just an executable script that calls the main function. Well, it loads your lab1.cl. So this is kind of like a hash include in C++. So make sure it's in, it specifies where the interpreter is, which interpreter to use when you're evaluating this. Loads the lab1.cl file, so it's got the definitions of your three functions, and runs the main routine that's in there. So at the moment, if we were to run test1.cl, basically just says, okay, main called. Now, when I'm marking your labs, once you've submitted these, I'm going to be marking your lab1.cl, not your test1.cl. So your test1 is just so that you can actually come up with scripts if you want to test your Lisp code. So again, you can modify test1 as much as you like, put in whatever kind of testing you like, call whichever functions you like. And if we take a look at our lab1.cl, we've got the three functions. So if I wanted, for instance, my test1.cl to call my checker function, just to see if it's actually working, then I could quite happily say, okay, let's try a call to checker with, I don't know, 3 and nil. So I'll call checker and pass 3 and nil. And again, we'll try running test1.cl, and it should call main, and then it should make that call to the checker function. All right, so there's the, in test1, we called main, which had that format in it that just printed out, okay, yeah, you called the function. Then this statement was coming from our checker, or from our test1.cl rather, and then this is from the actual function call to checker, right, where it's printing out, oh yeah, somebody called me and they passed me these two values. So that's all that's in there right now. And again, you can play with this as much as you like to wind up testing your functions, and I'll come back and talk about that more in a little bit. All right, so what we're doing in Lab 1 is, again, basically just going through and practicing with lists, with I/O, playing with function calls and returns, playing with recursion, using it to load. You're probably going to want to experiment with some of this interactively as well. So again, if you want to try playing with any of this stuff interactively, you can run GCL, right? You can load a file, so I can say load lab1.cl, right? So it goes off, loads whatever's in that file, and then I could try calling it manually here, checker 10, and again, checker is ultimately going to be expecting an integer in a list if I remember correctly, so I'll just give that a try. So we'll call checker, pass it an integer, pass it a list, and again, all it's doing right now is printing out what parameters it received. So you can quite happily play with this stuff interactively, or play with it through your test1.cl script. All right. So again, what we're aiming to do is to complete those three functions according to the specs for them. Other than comments, don't put anything in your lab1.cl other than those three function implementations. So again, no global variables, no extra functions, no hash bang, all that sort of thing. If you stick in the hash bang, it won't be able to load properly. Again, don't use global variables at all. So remember, if you use setf and a variable name that isn't already declared, that's effectively acting like a global variable declaration. So don't do that. I'd really like you to just stick with without the use of variables at all if possible. And again, we'll play with that some in the lectures and whatnot. All right. So you want to make sure your three functions actually adhere to the specs. So when I give an algorithm here for the processor function, for instance, follow that algorithm. Don't rewrite it to do something else. Even if you accomplish the same thing, I want you to actually go through and implement this algorithm to get the recursion working the way it's expressed here. Let's see. Again, just make sure everything follows the specs. So you've got a checker function that is pretty much just error checking the parameters it's being given. So it's expecting two parameters. They're named n and l in the parameter list. So n is supposed to be an integer, l is supposed to be a list. So you're going to use the type checking functions to go through and say, well, if n isn't a list, return the error symbol. So again, the single quote and the word error is basically saying this is a symbol I want to return. So it's actually going to return error as, if you like, a special symbol. So check if n is an int. If not, return error. If l is not a list, return error. And if you get past that, then we're going to see if the number of elements in L is bigger than n. So if n was 3, you want to make sure that L is a list of more than 3 elements. So there's a length function in lists. So you can just check if length L is greater than n, you're good. So if it's long enough, return t. And again, remember that's true in Lisp. And otherwise, return nil, which is essentially false in Lisp. So this is going through, checking the parameters, and seeing if n is actually less than the length of L, pretty much. The main function is going to get, I'll come back to processor in just a sec. The main function is going to get the user to enter two lists. It's going to call processor, and what it's going to do is read those two lists and pass them directly to the call to processor, and then display the results. So we want to do a read. Well, actually, we want to do two reads to get the two values, and we want to pass those two reads as the parameters to processor, right? Because again, we're trying to avoid the use of variables here. Just get a little bit of functional programming practice in. And then we want to display the result. So we're essentially doing a format where we're displaying the result, the return value from the call to processor, that's taking two reads as parameters. So just as kind of a bit of an idea of what we're looking at here. So I'm just going to do an example with a single parameter. So if I wanted to do something like display the result of square root of some value the user enters, which is essentially the kind of idea we're doing here, then I'm saying, okay, the root is, maybe I'll say, yeah, why not? Root is my tilde a tilde percent, and again, remember the tilde a is the placeholder for where the value is going to go. The tilde percent is just a new line, and then I want to run square root on the result of calling read. Right, so what's going on is that read function is going to run. It's going to grab whatever the user types in. It's passing that to square root, which is computing the square root of it, and returning it so it gets displayed in my format statement. So it's going to sit here and wait for me to type in something. So I don't know, I type in 36, and it comes back and tells me that, okay, it read it in, passed to square root, that got passed as the parameter to the format, and we get the result. So that's the kind of thing that you're doing. It's just you're doing two of these reads and you're calling processor. So that shouldn't actually be too bad. It's just getting used to the functional side of things. All right, so that's the main routine is actually pretty straightforward. The checker is pretty straightforward. It's just getting used to using things like int p and list p and length and whatnot. And then for the processor function, this one's going to be recursive. Again, I've laid out the algorithm here, so it isn't actually too terribly complex, but it gets everybody used to doing this stuff. So again, processor is expecting two parameters. It figures they should both be lists. So the first thing it's going to do is check if the first parameter is a list, and if not, return error. Then it'll go through and check if the second parameter is a list, and if not, return error. And if we get past that, then we'll see if either of them are empty. So if the first one is empty, if the first one is null or the second one is null, we'll return nil. And if we get past that, then this will be the general case. So this is, if you like, the error checking for the function, the base case for our recursive function, the point where the recursion stops, and then the general case. So our final else, if you like, or our T if we're using a cond, our final case is saying, okay, well, I'm going to do a cons. I'm going to call checker on the head of both lists. So remember, checker is expecting two parameters. So I'm going to get the car of the first list and the car of the second list and pass those to checker. And whatever checker gives back is what is going to be the front element of this list that I'm building. So I'm going to return cons of essentially the head of list 1 and the head of list 2. And then the second parameter to cons is going to be my recursive call to processor. So I'm going to call processor on the tail of list 1 and the tail of list 2. And so this will be the one that's obviously the most work, and essentially the idea is to get everybody used to debugging Lisp, right? Just to make sure you get a bit of a play with our recursive functions and getting used to the appropriate use of brackets and function calls and whatnot. Because for the most part, the syntax issues people run into are, you slip into C-like habits where, instead of, where I want to do something like, if what I intended to do was to get the front of some list. Right, so again, car gives us back the front element, cutter gives us back the tail, right? Everything else. What tends to happen is somewhere along the line you just slip into old habits of saying, well, I'll call car on, the list 1, 2, 3, 4. Let's actually try it this way. And you'll get all sorts of weird and wonderful Lisp errors, right? Because it goes through and says, it sees this outside a set of brackets and thinks, oh, gee, that must be a variable name. Right? For it to be a function call, it actually has to be the first thing inside there. Or you forget the single quotes and you try something like the car of 1, 2, 3, 4. And again, what it thinks then is that this is a function call and 1 is the name of the function. And so again, you're going to get weird error messages where you get this one, datum 1, where we expected a function. And that's usually, if you get this kind of a message, type error, datum, and expected type is a function, usually that means that you've forgotten to throw a single quote inside something that's meant to be a list. However, you'll have lots of fun getting used to playing with Lisp. Again, don't forget your adds and commits and pushes at the end of this. I've run through a sample run on a couple of the calls to the different functions and what they should do, right? Checkers expecting an integer and a list, and we want to see if the integer is less than the length of the list, right? So just a few sample calls. And then I've given you a list of things to try testing down at the bottom of the lab. These are the kinds of things that I'm going to test your program on. So you should go through, make sure you figure out what should be the behavior, and then see if you can come up with a test case in your test1.cl, for instance, that actually checks this. Or have your test1.cl prompt the user or something like that, and then call checker, or prompt the user and call processor. Whatever you like, but do make sure you go through and start doing reasonably robust testing on your solutions before you submit them. All right, I think that was everything I wanted to say.